Differentiation from first principles. Now, the only time you need to use differentiation from first principles is if they ask you specifically differentiate from first principles. Otherwise, we use the rule. But very doable, so we make sure we can do that. But on top of that, it's very important to understand where differentiation comes from, and that's what first principles is about. So it is effectively the slope formula if you don't have a line, if you have a curve, okay? And instead of getting the slope of a line, we get the slope of the we don't get the slope of the curve, we get the slope of the tangent of the curve, but there's a little bit more going on. So let's remind ourselves and work way through. Okay, so traditionally we're using the slope formula. Okay, let's say we have a point here, x1, x2, and we have this point here is y1 and y2, and we name this x1, y1, that point, and this point x2, y2. Slope is rise over run, how much it rises or how much it runs. The rise is y2 minus y1, and the run horizontal change is x2 minus x1. So that should make sense from there. Okay, you won't be asked any of this, it's just to give you the feeling for it. Okay, background. So m is y2 minus y1 over x2 minus x1. However, when we're dealing in functions, okay, we generally talk about, instead of y, we talk about f of x, okay, which is the same thing. Okay, so remember in our function, okay, we put our x in, we do the function f of x, and what comes out is what we call y or what we call f of x. And generally when we're doing differentiation, we call it f of x. We can call it y, but generally you'll see it's f of x, okay, and then we got f dash of x for differentiation. Okay, so we're going to redraw this in the same way, okay, but this time instead of saying x1 and x2, I'm going to say x, okay, so I'm going to draw the same line, okay, and what I'm going to do is, to make it interesting, okay, I'm going to call the first one x, okay, and then I'm going to say that the extra distance here is h, okay, so this point is hopefully pretty obviously x plus h, and up here, this is the function f of x, okay, I'm still using a line, okay, f of x, and this is this point here, okay, corresponding with that, is going to be f of x plus h, so f of x plus h. So this is x, this is the y value for x, which we're calling f of x. This is x plus h, this is the y value, f of x plus h. Okay, so what we're doing, we do a rise over run again. Okay, so the rise is f of x plus h minus f of x. So that value for y minus that value. And then rather interestingly, the run is x plus h minus x, so it is obviously that distance here, we've just said it's h. So our slope formula, I'm going to put it beside here, becomes f of x plus h minus f of x over x plus h minus x, which rather interestingly just becomes h. Okay, and those of us who remember first principles, this should be becoming quite familiar to you. Right, so let's take it one step further. Okay, and we start talking about a curve. So instead of having a line, we have a curve, and we take the tangent. Okay, we take the tangent, we should cut it in one point only, not very well drawn there. Okay, now I'm going to zoom in on that, make this bigger. Okay, and I'm going to have, so we're going to see it like this. And this is our curve, and we're going to take 2 points. One on the curve and one slightly off the curve. Okay, and I'm going to take the point. Okay, so what I'm trying to show here is that this is the actual tangent, that's the point, that's the tangent, and this is a point a little bit further on. Okay, so I'm just going to draw it in. Okay, and I'm going to call this h. Okay, and I'm going to call this f of x, and I'm going to call this f of x plus h again. So what I'm saying to you here is basically what I have is this formula. Okay, I still have this formula, x plus h minus f of x, you see that you can, over h. Okay, that's fine, right? But what we want to do then for differentiation, and when we get f dash of x, is we want to make h as small as possible. Now you can't make h 0 because you can't divide by 0. So mathematicians are very good at cheating. Okay, so what they do is they get a thing called a limit. And all we have to worry about the limit is the limit as h approaches 0 means we're making h as close as possible to 0 without making it 0. Because we want to make this point as close as possible to here to make it accurate. In other words, we basically want them to be on the same point. We can't have it on the same point because h will be 0, so we get what's called the limit. So we call it f dash x, and we say the limit as h approaches 0 of all of this. F of x plus h minus, sorry, I'm going to put the h up here over the way, f of x over h. And that is that's differentiation, okay? And you're going to see now when we do it on paper in a minute, and where it'll be relevant, you have to learn and make sure you can do it, is we're going to use this guy, okay, to get to differentiate from first principles. But I think the important thing to remember is where this comes from, because it's easier to learn it then, okay? So it's f of x plus h minus f of x over h, limit is h goes to 0. If you understand that, it makes doing the first principle easier later, okay? Let's get clear. You will not be required to show this, okay? All you have to do for differentiate from first principles, what follows, be able to differentiate things from first principles. This is background to give you an idea, but I will be coming back to this when we're doing slopes of tangents, when we're doing a rate of change, max and min and all of that. Everything we do in differentiation is basically because differentiation is just slope, okay? It is slope of a tangent to a curve. It is the slope formula gone mad. Thank you. Bye bye.